So what I want to show over here is see this Java technology platform. So you see .java file. When it is compiled, what gets created is a .class file. Okay. So .class file is called as a Java bytecode. Okay. And you will see that this .class file that is created, okay, is then executed by JVM, that is Java Virtual Machine, Java Runtime. Okay. And you'll see that this JVM is different for different platforms. Like JVM for Windows platform is different, JVM for Solaris is different, JVM for Macintosh is different. The .class file is same. When you compile the Java file, it gets compiled into a, it doesn't directly get, when you compile, it doesn't get directly converted into a machine level code. Okay, it gets converted into some intermediate code called as bytecode. Okay, bytecode is then executed by Java runtime machine, and it converts bytecode into machine level code and executes it on your particular machine. Okay, so that is a difference. Normally, if you are working with C++ technology or C programming, you know that in Microsoft related technologies, when you compile a .c file or .c++ file, it gets directly compiled into, it gets compiled into and converted into a machine level code directly. Okay, and that machine level code is specific to that particular platform. Means once you convert a .c++ file on Windows operating system, it will be converted into machine level code which is specific to Windows operating system on that particular machine. Okay, if you try to take that machine level file which is now compiled, okay, if you take that C++ compiled machine level code into some another computer which is of different platform, say it's first one was 32-bit and this one is 64-bit with different operating system, and you expect that it will work and get executed there, it is not going to work, because when it gets converted into machine level code is always based on the hardware details of that particular machine or platform. Okay, operating system of that platform, it is tightly integrated with it. So you cannot move a machine level compiled code from one platform to another platform. Okay, so that's why the C.C file or .C++ files, those files, we don't say that C and C++ are platform independent code. They are platform dependent. Okay, so wherever you will compile it, there only you have to execute it. Okay, but with Java, we don't say like that. With Java, we say that Java is platform independent technology. Okay, it's platform, it's portable, we say. Portable, it's platform independent. How does it become platform independent? Because when you, in Java, when you compile a Java source file, it doesn't directly get converted into machine level code. It gets converted into some intermediate code called as bytecode. Okay, so that .class file has that bytecode. Bytecode is somewhere between a source code and a machine level code. It is somewhere between that. Okay, this bytecode is portable. Okay, so you can create a .class file on Windows operating system and then send this bytecode .class file. You can send it across to the some another operating system. Say you can send it to a Solaris operating system on another machine, and there then the same .class file can then be executed by the JVM which is specific to Solaris. Okay, on that platform it will then execute it, convert it on fly into machine level code and then run it. Okay, so the .class file is portable from one platform to another platform. It is same for all the platforms. But then what is different? The difference is in the JVM. The final JVM, which will convert that bytecode into a machine level code and then execute it on that particular machine, that JVM will be dependent on that specific platform. So when you want to run a .class file on a Solaris machine, you need a JVM specific to Solaris. If you want to execute .class file on Windows machine, you will need a JVM specific to Windows. If you want to execute a bytecode on the Macintosh, then you will need a JVM specific to Macintosh operating. Okay, so you see the portability thing, they have shifted it from dot class file into the JVM. So your dot class file is portable, but JVM is not portable. Okay, and that is okay, that you don't have problem with it, because when you create your project and you want to send the project files to your client or to some another third party, you just have to send the dot class files, zip and send the dot class files to that particular party. Okay, whatever platform it is going to execute that dot class file. Okay, if you have created written a code and compiled it on Windows, but then you send that dot class file to your um, testing environment at client side, and they want to execute it. If they want to execute it on Macintosh, they can take the same bytecode. But when they will execute it on Macintosh, they will need a JVM specific to Macintosh to execute it. They cannot use Windows JVM there, because they are running that bytecode on Macintosh operating system. They will need JVM specific to Macintosh. That JVM they can download from internet. From internet they can get the Java runtime. If you will go to the Java site, you will see now it comes with Oracle. So if you go there, you will see JDK, which is specific to different platform. Java Development Kit for Solaris platform is there. Java Development Kit for Windows is there. Java Development Kit includes Java runtime, which is your JVM. So you just have to send the bytecode to that particular third party entity, or with whom you want to share your um, um, code. You can just share your dot class file. That particular person, depending on which platform it is going to execute it, he will download the JVM specific to that platform and then execute that bytecode there. Okay, you need not send JVM to that person. JVM he can get it from internet. You just have to zip your dot class file and then send it across. That zip also, I will tell you, when you zip the dot class file, you will see that you don't use a normal zip utility. Okay, similar to zip utility, there is a utility called as jar. Jar utility. Jar is Java archive. JAR is Java archive. It is used to zip your all dot class files together, preserving its folder structure. So when you create a Java project, your .class files need not be in a same folder. There might be different subfolders inside your main folder. So there might be a source folder. In source folder, you might be having different packages. Like you might have HR package in which HR related classes are there, accounts package in which account related classes are there. And when you want to zip the entire project and send it, you will use Java archive utility. Okay, in Eclipse, that is available. You can simply say export as jar file. Export my Java project as a jar file. Okay, by that it will export your entire project as a jar file. When it will export, you will see what it will export is, it will only export the bytecode, preserving the folder structure. So you have accounts folder in which there are account related class. Okay, then you have HR folder in which there is a EMP class. Then it will keep that folder structure as it is. Okay, and it will create a zip out of it. That zip file is called as a jar archive, Java archive, with the extension .jar. It has the extension called as JAR, Java archive. Okay, that way you can send the entire project across to the other person. When the other person receives it, he can just simply import that jar file into Eclipse. The way there is an option to export your project as a jar file, there is an option to import your Java archive as a Java project. You will import that jar file. When you import it into Eclipse, it will get converted into a Java project and it will be visible inside your package explorer as a Java project. Okay, and then he can execute it in the Eclipse. If he doesn't want to execute it in Eclipse, there is also provision that if you have a jar file, then you can directly execute it from command prompt. Okay, there is a command called as java-jar. Java is a command to execute your Java runtime. So just java-jar and whatever file name .jar. If you give like that, your jar file will be executed from command prompt. Okay, we will see that. How to do that, I will show you. Okay, main thing what I want to tell you is that over here, within jar, what will be there will be your folders. In those folders, there will be a dot class files. So these dot class files are portable. You can send it from one platform to another platform, and when you want to finally execute it, wherever you want to execute it, depending on that platform, you will need a JVM specific to that platform. So portability is moved out from dot class file into JVM. But that solves our issue. Our main concern was that the person who developed the code, he should be able to share his code across to some third party or some another agent or another or the client side. Okay. And that person should be able to then execute it on whichever platform he wants. Now that is easily possible. Okay. Same thing is not easily possible with C++ files, because C++ files, the moment you compile, then it gets converted into machine level code, which will be specific to your own platform where you compile that code. So now if you try to send that exe file, when C++ you compile, it gets converted into a exe, which is a machine level code. That exe is only executable in that environment. If you send that exe across to your third party client or to the some environment where you want to execute it on some another platform, another machine, it will not execute there because that exe is not specific to that environment. So then you are stuck. So now what you have to do, you have to send the source code to that person. He will have to get that source code and he will have to compile that source code on that platform itself. Okay, so suppose on Windows you compiled the code and you created a exe on Windows. You cannot send exe to the Solaris and it cannot be executed in Solaris operating system. So you will have to send the entire source code to the Solaris. And on Solaris machine, then you have to first compile that source code so that the exe that will get created will be specific to Solaris. So then it can be executed on Solaris machine. So there then, that's why we don't say that it is portable. In C++, the exe is not portable. You have to share the source code from one platform to another platform. But in Java, because your .class file is portable, you need not send the source code across. You can only send the .class files across to the another entity. That way you don't have to share your source code, no, and you are saved. It is a big liability. You have developed your code, and there are times that you have promised to give an application to an end user, working application. You have not promised to give a source code to that end user. Okay, so why you will give the source code unless and until it is not decided that no source code also should be provided. Normally, it's the working application in which the customers or the clients will be interested. So what you will do is you don't have to send the source code, just send the Java archive which has your bytecode inside it, and there then they will execute it on whatever that platform they want to try it out. Okay, so that's why you say that Java is platform independent or Java bytecode is portable. Okay, how they have done it, that you have understood. What trick they have used by moving out the dependability, platform dependability, they have moved out from the .class file into the JVM. Okay, that's it. So that is about the Java technology platform that I want to tell you. And obviously, I have already in Eclipse, I have already showed you that when you create a project like this Java basic OOPS project you have created. So I have already told you that when you create it, where it is located, resource may, you will see the workspace location. This is the place where it is created, right? So if you go over here, if you go over here, which is that location, this is that location, no, Java basic OOPS. See that in this, the source folder has the folder structure inside it. And this is a .java file, right? But I said that similar to source folder, there is bin folder also in which you have a corresponding .class files which gets compiled. In our first session, I showed you that. Now I will also show you that here, if you right click it, there is an option export. Okay, so you have to select that option export, and you want to export it as a Java archive, right? So go to the Java and then export it as runnable jar or jar. Sometimes you want that you want to export an entire application along with the main method inside it, because you want to execute it. Sometimes you have dot class files inside it, but you don't have any dot class file which has a main method inside it. So you just want to share certain classes, but don't want to share an entire application. Entire application you are sharing means there has to be one of the class with a main method inside it, so that it can be executed at the other end. Okay. So for example, here when we want to export this project, we know that this is going to have a main method. It either you can say that this is the class where I want to execute it, or you have a one more with the main method over here. So you can give which is the main starting point of your application. Normally this will not be the case. If there is a single project, in a single project, normally there will be only one class with a main method. There will not be multiple classes with main method, because when you execute an application, there will be only one starting point of your application. Right now, for convenience purpose, I have just for running the program, I have added main method inside use emp also and hello world also. Generally, there will be only one class called as main app class or app class, which will have your main method. Okay. So right now you can decide which is the starting point of your application when you export it. So suppose I say export as runnable jar file. So when you say next, it will ask you, okay, which launch configuration means which is the starting point class where main method is written. Now we have main method in both these classes, so it is showing both the classes. Had it been that there is only one class with a main method, it will show only one class. Normally in your project there will be only one class with a main method, so you will have to pick it up from here, from this drop down. Right now, because there are two classes with a main method, it is asking you which one you have to pick out of those two. So let's say I want to execute use EMP, because we have created a EMP object there. Let's use that. This is the starting point of my application. And where do you want to create a jar file and where you want to export it? So export destination it is asking. So let's create a export destination over here. I want to export it over here. Let's export it over here and let's give some file name. Okay, Java basic oops dot save as type. You want to save it as .jar file. So say save. Okay, so see, export destination, library handling, extract required libraries into generated jar file. Let it be. And just say finish. Jar export finished. Okay, let's see where it has created the jar. See, here is the jar file created. Okay, now if you want to execute it, see this. So there is a java dash jar command, and we are already in that directory where your jar file is there. If you are not in that directory, then यहाँ पे java basic oops.jar, you will have to give a complete path saying c:\/ java track wit underscore 2024 / java basic oops.jar. But I am already inside that directory, so I can directly give a command java dash jar. Now, when I say Java, what is going to happen is it's going to execute the Java runtime. Java runtime means what? The same thing. Same thing over here. When I say right click over here and say run as Java application, what happens? Same behind the scene, this run as Java application is same as giving this Java command. Java, whatever file name. Here we run a .java file. There we are running a jar file. So, but what I am trying to say is when you say run as Java application, your JVM gets launched. Okay, and it runs the .class file with the main method inside it. Okay, so in Eclipse you can say run as Java application, but suppose you don't have a Eclipse and you want to run it from command prompt, then what is the command to execute your .java file or a .jar file? The way you are executing .jar file, you can execute a .class file also. You cannot execute a .java file because .java file तो compile होती है ना. .java file JVM execute नहीं करता है. .class file JVM execute करता है. ओके तो जावा कमांड के साथ आप या तो डॉट क्लास फाइल रन कर सकते हो, या अगर आपने उसको जिप किया है जावा आर्काइव में, then you can run it as a Java archive like this. Okay, so what is the command? Java dash jar, and you can execute it. Now when you give this command, how it understands that where it should find the main method? You remember when you exported it as a jar, it asked you the launch configuration. That launch configuration means you gave the starting class, the class where the main method is there. You informed it, no, while exporting, that this is my class where my main method is there. Why did you give that detail? So that when you give java dash jar command from this jar file, how it will know where it has to search for a main method. You have mentioned that launch configuration as usemp dot java, so it will go there, it will find its dot class file, and then it will run it. So like that, you can run it from command prompt. If you want to import that Java basic hooks, you can again import that archive here. If you try to import it,